Hello everyone, my name is Emanuele Giuseppe Esposito, and in this demo we will talk about securing data in use. Why is it important and what are the challenges behind it? So let's start with the types of data. There are three different categories of data that we want to protect. There is data in transit, which is over the network connection, and today we have a lot of libraries like OpenSSL, TLS, and so on that make sure that data in transit over a network connection is encrypted. So if somebody tries to read it, he won't be able to get any information. Same applies to data at rest. Data at rest is about storage. There are techniques like LAX or new PG that make sure that the disk, when it is not used, it is encrypted so nobody can read it. And then eventually there is data in use. And confidential computing is about protecting data in use because at the moment there is no standard to protect data while it is being used in the memory. Let's do a practical example to see all these three kind of data used in a single example. So we have a container, in this case, that is performing, first of all, a connection using HTTPS, so encrypted connection with a remote server. It is fetching a key from the server called volume key, and it is using this key to decrypt a storage, a volume that is attached to the pod to get the data inside of it. Inside of this storage, we have a workload, which is then run, and obviously runs in memory. After running the workload, the key is deleted and the storage is again sealed. So let's see a memory scenario when an attacker or rogue system admin tries to access the memory. We will have three examples: a normal RunC container, a kata container, and a confidential container. We will see all the difference later on. The malicious user tries to dump the memory and tries to read it. We are showing all three types of data security together here, as I showed you before. The program used to get the memory dump is gcore. Gcore is a very common package, which is part of the GDB package, and its ability is that the attacker can, or anyone, use to debug, and it is able to get the whole memory without stopping the program. So it is able to dump the whole memory or process without him noticing it. Let's see what with RunC containers what happens. So let's start with the RunC example. So we can see that I create a normal RunC pod. We can see that it's also up and running on OpenShift. Let's look what happens inside this pod. So first of all, we are getting the volume key and storing it in memory. So we use HTTPS connection to fetch from this remote server this file called volume key, and we saved in a memory file system under volume key. This memory file system is just a temp.fs. So then we decrypt and mount the volume. So we have an encrypted volume here, and we use cryptosap to decrypt it, to open it, using the key that we just got from the remote server, this volume key. After we decrypt it, we then have access to the workload and we run it. And we can see that it's up and running. After, we clean up and sleep. We used to sleep this 44444 that will be later used to find the process. So now a malicious host tries to read the secret. So using this 444, this is just an example, there are several ways to find the bot and it's legitimate. We can find that the process that is running in the operating system. So we get the process ID and we use gcore to dump the memory of this process in a file. This is pretty straightforward. Now we use strings to find a secret, so we look for this secret string, and we can see that we found the secret. So what went wrong here? The problem is that the admin, the rogue system admin, can still access the memory. While the network and the storage are encrypted, the rogue system admin can still get a memory dump and can still fetch a secret. Let's look now what are kata containers and what they try to solve. The difference with a normal pod is while the normal pod runs on an application platform, the kata containers are pods that run inside a kata virtual machine. So the pod is not running on the application platform, but is running inside a virtual machine that internally has its own operating system, which is then in turn running on the application platform. So there is an additional layer of protection. The advantages of kata are, first of all, isolation between workloads. Each workload, each pod cannot interfere with the other, even with the elevated privileges, for example, for CI/CD pipelines. And also isolating the cluster from the workload. A workload cannot perform operation on the cluster, like accessing the node. Let's look now at a demo with a kata container. Let's now look at the kata example. We have created our kata container, which is, you can see, has been created and it's also up and running. Let's try to see what happens inside this pod. What happens is exactly the same as the run C. So we get the volume key and we save it in memory using HTTPS. We can see that it already happened and it went fine. Then we use the key to decrypt the volume and mount it to get the workload inside of it. And as a key, we use the volume key that we just got. And then we run the workload, and we can see that it's up and running. Then we conclude by cleaning up the resources and sleeping. Now the malicious host tries to get a secret. Again, it tries to find the process ID, it's easy to find, and we can actually see that this is a kata container because it's running QEMU. It's not anymore the sleep command, but this is a virtual machine. Anyways, now that we get the process ID, we get using gcall to get the memory dump. That is also pretty fast. And after this, we try to look for my secret. And we can see that we can easily find the secret. So what went wrong here? The issue is that despite kata containers offering an additional level of isolation, a rogue system admin can still dump the memory and access the secret. So the problem is not yet solved. Let's look now into confidential containers. The idea of confidential containers is similar to the kata containers. So the pod is running in a confidential virtual machine. So again, a virtual machine that offers an additional level of isolation, but the confidential virtual machine is backed up by hardware trusted execution environment, which is hardware that actually enforces memory encryption. So the advantages of a confidential container are the same as kata, so isolation between workloads and isolate a cluster from the workload, but they also add the additional protection of isolating the workload from the cluster. So the cluster admin or the infrastructure admin or the system admin cannot see or tamper with the workload and its data. Let's look now at a demo with a confidential container. Let's now look inside the confidential container example. So we create our confidential container. We can see that it's up and running. And now we try to inspect what's happening inside this container. And again, we have the same process. We get the volume key from HTTPS. We store it in a memory file system. We decrypt the volume using this key. And then we run the workload. We can see that it's up and running, we clean up and sleep. Now malicious host tries to get the secret. We again find the process ID, this is very easy. We can see again this is a virtual machine. Then we try to get a core dump. It worked also this time. But now if we try to search for the secret inside this memory dump, we can see that nothing is found. So why did the attack fail this time? The reason is that the hard-to-trust execution environment, together with a confidential virtual machine, makes sure that the memory is encrypted. So if a system admin tries to dump the memory, it will actually find something encrypted, and the admin actually will not get the encrypted file, but a zeroed result. Because the TE also makes sure that not even the encrypted portion is returned to the user to avoid the replay attacks. So how to use confidential containers and kata containers on OpenShift? Introducing the OpenShift Sandbox Containers operator. This operator is available in OpenShift Marketplace and offers both solutions, kata containers and confidential containers. The operator offers this kind of solution for on-prem environments or also public clouds that do not support nested virtualization. And it's very simple to use. Once it has been configured, you just add the runtime class with the specified runtime class offered by the operator to choose between kata containers or confidential containers to the pod YAML, and the operator will do everything for you. Let's look at the sample I just showed you before. In this case, the commands are always the same and the pod setup is always similar to any normal pod. The difference is that I add the runtime class. In this case, I added kata cctdx to make sure that this pod will run on a confidential container, backed up by the Intel TDX technology in this case, which is a hardware trusted execution environment. Whereas in this other case, I use kata, which is normal kata virtual machine, so there is no TE. And you can see also here the syntax for the pod is always the same. This concludes our demo. Thank you and bye.